Welcome all. Our topic is computer memory. So, why do computers use memory? A computer uses memory to store programs and data. So, a computer may store data, may need to store data on which it has to work in memory, and the work which it has to do, which a program tells it what to do, is also stored in memory. A program may be an application program, it may be even operating system. So all these things, whether it be operating system, whether it be an application program, a utility program, any program, that obviously needs to be stored in memory. And the data on which the computer has to operate, to make calculations, to manipulate, to update, to transfer the data, that is again to be stored somewhere, and that somewhere is called memory. Computer memories are of various types. Computer memories include registers, they include cache memory, another type is main memory, and there is another type called auxiliary memory. What are registers? They are the registers here implies the CPU registers, the registers that are inside a CPU. A CPU is the central processing unit of a computer. So we know that a central processing unit consists of an ALU part, an arithmetic logic unit part, then there is a CU part, the control unit part, and then there is a small MU. This small MU, which is memory unit inside the CPU, it is actually a set of registers. So few registers, maybe 8, maybe 16, and in modern computers, it may be 64. So that set of registers is called, that set of registers becomes the MU of a CPU. Then the second is cache memory. So the cache memory is a special type of memory that a computer uses with the intention to increase, or in other words, we say with the intention to decrease the excess time, which other words mean is increasing the speed. So to decrease the excess time of memory, a computer uses cache memory. Some may also call it cache memory. So it is a fast memory nearer to the that CPU. It is actually in between the CPU and the main memory, and the main intention, main purpose of this memory is to increase the speed of transfer, data transfer. And then there is the main memory. The main memory is includes RAM, it includes ROM. So there the programs that are run by a computer are, or the CPU is just to run these programs. It is currently running those programs, or is about to run certain programs or use certain data. That thing is present in main memory. And that part of operating system which a computer needs to run is also present in main memory. And another type of memory is auxiliary memory, which is the backup memory, the backup storage. So it includes your hard disk, the other types of backup things which we use. So there is a set of magnetic disks, magnetic tapes, the optical disks, and other things that come under the heading auxiliary memory. Now let us have a look at memory hierarchy. If you look at your screen, there is a pyramid like structure. What is this structure? This is an arrangement of various types of memories, and the arrangement is in terms of their access time. So the fastest is at the top, then the second, then the third, and like this. So the first is the registers. So the registers are within the CPU, and the access time of registers is very less. Then on second number is the cache memory, which has a greater access time than registers, but less than that of main memory. And in the same way, at the third position is the main memory, which includes RAM and ROM. The fourth is the magnetic disk, then it is the optical disk. The example of magnetic disk is hard disk, floppy disk, and optical disk is there then, which includes the CDs, DVDs, and at the bottom then there is the magnetic tape, which is the same which you might have seen in old times, the cassette uh, of a tape recorder. There is a tape inside it. It is a magnetic tape. So it is also a storage thing, memory thing. And if you look at these arrows on the right and left hand side, what are they depicting? They are showing that as you go down this pyramid, there is an increase in the access time. Access time means the time taken to transfer data from the memory to CPU, to the processor. So the time taken to transfer data from a register to an ALU is very less as compared to cache, and cache is less as compared to main memory, and so on. If you see on the other side that the capacity, there is an increase in capacity when you go down the pyramid. That means that in a computer you will find hardly 8, 16, 64 registers. That's it. So the capacity will be very less. The cache memory, again, it will be greater than the capacity of registers, but very less than that the capacity of main memory. So the cache memory, it may be 512 kilobytes, it may be 1 MB or 2 MB in modern computers, PCs, and that is it. Then main memory. So we know very well that currently we have main memories in a normal laptop. In a simpler PC, we have RAMs of 4 GB, 8 GB. Fine. So the main memory, even in mobile phones nowadays, we get 2 GB, 4 GB RAM. Okay. Then if you go to magnetic disk, it will be even larger. So you will see a laptop usually with a magnetic disk of 512 this what we call half a TB, 512 GB, which is half a GB or half a TB, or in some you may find even 1 TB, even greater than that. So then further you go down and it usually increases in, there is an increase in capacity. Okay, now if you go from bottom to top, you will see there is an increase in cost per bit. Means to store 1 bit is costly when you go upside, and this is the reason that the capacity is increasing towards the bottom. Since the cost per bit of a magnetic disk is very less, so we usually have half a TB or 1 TB magnetic disk, but the cost to store 1 bit in cache memory is very large. So we usually keep small cache memory in computers because we cannot afford larger cache. They will be very, very costly. So this is the reason that we have a structure, a pyramid like this.